Hello everyone and welcome. In this video we're going to be taking a look at another advanced Windows privilege escalation technique, namely DLL hijacking. So again, before we even begin exploring DLLs and hijacking DLLs, let's understand what the technique is about and how it works so that we can then implement and test out the technique for the purpose of privilege escalation on Windows. So what is DLL hijacking? DLL hijacking is a privilege escalation technique where an attacker manipulates the way Windows applications or programs load dynamic link libraries, or DLLs as they abbreviated, to execute malicious code with elevated privileges. And this technique exploits the default search order for DLLs in Windows to replace or inject custom DLLs into an application or for an application to use, leading to privilege escalation. So DLL hijacking occurs when an attacker is able to control or influence which DLLs a Windows application loads at runtime or when the program starts. And Windows applications rely on DLLs for various functions such as, accessing system resources, performing tasks, or providing application-specific features. And by manipulating the DLL loading process, an attacker can inject malicious code into an application, potentially leading to privilege escalation. Now, in terms of how this works, you obviously have the default DLL search order. So Windows applications or programs use a default search order to locate and load DLLs at runtime. So let's say you have a Windows program and it loads up a set of DLLs, either Windows specific DLLs or custom DLLs. When a program starts up, it follows a predefined search order in order to find those DLLs. So this order includes several locations, such as the application's directory or where the application has been installed. That's typically the case. System directories and system defined paths, which we'll actually take a look at shortly. But the bottom line is that if a DLL is not found in the expected location, Windows moves through the search order until it finds the required DLL. So let's say a program is looking for a DLL called test.dll. Well, it'll firstly start off in the program's directory or installation directory, or the directory from which the application is running from. If it doesn't find it there, it'll then move on to other directories, and until it finds the DLL, it'll continue searching and utilizing the search order to find the DLL. If it doesn't find the DLL, then again, it'll not load the DLL, obviously. But the bottom line is, I want you to pay attention to the search order, and the reason for that will become apparent shortly. Now, in terms of, what comes next, that's obviously exploiting the uncontrolled DLL loading. So an attacker can exploit this search order by replacing or by placing a malicious DLL in a location where it will be loaded instead of the legitimate DLL. And if the application runs with elevated privileges, or if the program is executed or is run by, let's say, the administrator user, the DLLs that are loaded will consequently be executed with administrative privileges. And if the DLL that, again, we use as an attacker or that we replace as an attacker is, let's say, is an MSF Venom DLL, then we'll get a Meterpreter session with administrative privileges. So in terms of how this privilege escalation technique works and the methodology behind it, I've sort of laid out what the typical steps, or the steps that you typically see when performing DLL hijacking for the purpose of privilege escalation. So step one is identifying vulnerable applications. What does this mean? It essentially means looking for programs that, again, are programs installed on the target system that are running under specific, or are running with specific privileges. But again, this is not really set in stone. So you determine privileged applications, and then you analyze. This is very important. We analyze the DLL dependencies. So we just take an application or a program that's on the system, and we analyze its DLL dependencies to see what DLLs it actually calls and then identify using the search order whether the DLLs exist. If, for example, if it's a program-specific DLL, not a Windows DLL, does it exist within the program's installation directory? And if it doesn't exist or is not found, then we could potentially generate our own DLL with the same name of the original DLL that the program is calling, and have that, and have the application load in our malicious DLL. However, remember, in order for us to do this as a standard non-privileged user, we should have the permissions, or we need to have the permissions to make changes to the folder from which the DLL is being called. So if it's calling it from the default installation folder, or where the program has been installed, and we cannot make changes to that folder, or we cannot, write to that folder, then it'll not work. So it's very important. Those are really the two prerequisites that are required in order for this to work. So step 2 is examining the DLL search order. So understand the default search order. So Windows has a predefined order for searching for DLLs, and it generally starts with the applications directory, followed by the system directories, and then other system defined paths. And you're really looking or identifying potential insertion points. And you're sort of determining where in the search order an attacker might place a DLL so that it gets loaded by the application. And some common locations include the application's current working directory, the system32 or syswow64 directories. But remember, whatever the directory is within the search order, you need to be able to make changes to it. And that's very important. And then, of course, directories listed in the path environment variable, and other directories included in the search order. And then finally, you inject a malicious DLL. So you create a malicious DLL with the same name as a DLL that is missing or not found by the application when it is loaded or started. And this DLL will obviously contain, or will be, the attacker's code or payload for either command execution or to establish a reverse shell. And then you place the malicious DLL in a strategic location within the search order, so where the application is likely to look for it. And this can be done by analyzing a process, which again we'll actually be doing shortly. But the goal is for the application to find and load the malicious DLL instead of the legitimate one. If the legitimate one doesn't exist, we're pretty much giving it one with the same name, but again is malicious. So that's very important to keep in mind. With that being said, the best way to again visualize and understand and conceptualize DLL hijacking is to again perform it manually or practically through a lab. So this video has a lab associated with it, and it's going to be the lab just below this video. This lab will provide you with access to a Kali Linux system as well as the Windows target system via RDP for obvious reasons. And this particular technique, at least in terms of understanding how it works, will require RDP access to a target system and specifically the procmon utility, which is part of the sys internal suite of tools, in order for us to identify, potentially missing DLLs, etc. So with that being said, I'm going to fire up the lab environment, and I'll see you in the lab environment in a couple of seconds. Alright, so I am in the lab environment now, and as you can see, you'll be provided with your unique target machine IP address. So remember that in your case, or in your lab, your target machine IP, and consequently every IP within this lab, more importantly, your Kali Linux IP will be different. The only reason I'm stating this is in the event you're following along with this video or demo within your own lab, to replace my IP with the one in your lab. So important to keep in mind. So we'll have a Kali machine, or we have a Kali machine, the attacker machine, and the target machine, which we're really focused on the target machine, primarily because again, the attacker machine and target machine are the same system. It's just the attacker machine provides you with access to the standard student user, and then the target machine provides you the access via the administrator user right over here. So the objective is going to be to try and simulate what DLL hijacking exploit would look like in the context of privilege escalation. All right, so the first thing we're going to do is we're going to obviously start off with the application that we're going to be targeting, or the program we're targeting. So under the target machine tab, you can see that we have on the desktop a folder called DVTA. That's the target program or application that we will be again analyzing the DLL dependencies for. And if you go into the binary folder under release, you can see we have the application here. Now, before we do that, in order to analyze the DLL dependencies, we're going to use a tool called Procmon64. And I'm going to open it up first. And there we are. So first things first, let me just expand the columns here so it's fairly clear what exactly is going on, and I'll explain a couple of things. So first things first, let me see if I can increase the font size so you can see this a little bit clearly. All right, so I've increased the font size, and right over here, you can see that we can pretty much see the columns time of day, the process name, right over here, the process ID, the operation path, etc. First thing we want to do is disable or stop showing registry activity, because that's not really relevant, as well as network activity. So what is Procmon? Well, Procmon is a tool that allows us to view, pretty much everything related to what goes on when a program is launched and consequently running. So from our perspective, we want to see what DLLs the program loads, or analyze the DLL dependencies of a program. So what we're going to do to begin with is we are going to look for instances where the operation is create file. So I am going to right click on create file, and I'm going to include create file in my filter to just show create file operations. And again, this will make sense in a few seconds, but now we can start up the target application or program called DVTA, and I'm just going to open it now, and we're now going to see what DVTA does in the background with regards to its DLL dependencies as well as any other activity. But we're really interested in the DLL dependencies, or the DLLs that it is actually loading. So there we are. We can see that the program is fairly simple. It just asks us to log in. We don't need to interact with it, but we're now going to do something else now. So we are going to open up the filter, and we are going to say or specify the or create a filter for the process name, and we're going to say the process name is so we just want to filter out the for the process dvta.exe, okay, and that'll get rid of any of the other processes like Explorer, etc. So I'm going to click on add right over here, like so. So I'll just click on add, and looks like I added that multiple times. That's because my lab connectivity just went down for a second. So I'm just going to get rid of the duplicate. So DVTA, the filter is the process name, just hit OK. And now it'll only show, it's going to limit activity to just that of the process dvta.exe. And what we can do now is we can filter for the result and look for instances where a resource or a name is not found. So we can right click on name not found on any of them and just click include name not found, and just limit it to instances where specifically resources have been called or loaded and they've not been found. So let me just resize this accordingly, but we can see that specific to DVTA, and we're not going to be looking for Windows specific DLLs that are missing. We're going to look for DLLs relative or respective or that belong to DVTA. So here's one. We can see that this DLL, or the search order, the path that it's looking for the DLL is C users administrator desktop DVTA bin release. So it's actually looking for the DLL in the program's working directory, or where the program has been installed. In this case, it's on the desktop of the administrator user under DVTA bin release, and we can see that in that folder that DLL doesn't exist. So that's why, you know, Procmon is telling us here that the program is looking for that DLL, but again, it doesn't exist. So this is a potential DLL hijacking vulnerability or vector, but we still have to verify or confirm that we, as the student user, and I'll go back to the attacker machine tab because that's where we have access as the student user, we need to verify whether we have the privileges to actually make changes to that folder on the administrator's desktop. Now, again, this is a lab that is simply demonstrating the vulnerability. So in reality, you would most likely be dealing with a program that's installed, and, you know, it would be in its typical directory under program files or program files 86. So we can now utilize get ACLs to check for the actual ACLs for that folder. So we can say get ACL as we have done previously, and we specify the path to the folder or the service executable. So this is under users, administrator. This is in the desktop of the user administrator, and it's under the DVTA folder and under bin and release. And we're now going to just format this. So I'll say pipe and format, we'll say format list. And you can see that right over here, the owner is administrator, obviously, and access, entity authority has full control, administrators has full control. Student also has full control, which means, yes, we can make changes to that folder and consequently put in our malicious DLL in the DVTA bin release folder. And essentially, when we start up the program as the user administrator, we should get the DVTA should load that DLL because it will now be found. So we need to pretty much create a malicious DLL with the exact name of the DLL that it's calling. So dwrite.dll. And we just put it in that folder, and when we put it in that folder and the program is started, it'll search for the DLL, and if it finds it, which it will load it and execute it, and you know, we should be able to get an elevated session or elevate our privileges. So now that we've verified the two prerequisites, number one, we have a program that again you know, calls upon a DLL that is missing, and we can make changes to the folder as part of the search order, or where the you know, the locations in which the program looks for the DLL. We can now move on to the next step, which is generating our malicious DLL with MSF Venom. So I'm going to go back to the Kali machine here, and I'm going to open up a terminal, and there we are. So I'll now open up a terminal and just zoom in here. And the first thing I'll do is I will just get my Kali Linux IP. And again, in your case, yours will be different, so keep that in mind. In this case, mine is 10.10.4.3. So I can now say MSF Venom, MSF Venom, and we can say payload. We'll go for standard 32-bit interpreter payload, reverse TCP, and the L host is going to be our Kali Linux IP, or the IP address of the Kali Linux system. The L port is going to be just the standard 4444. And then the format is going to be of DLL. And that's the great thing about MSF Venom. We can actually generate payloads in the DLL format, and we're just going to call it the exact name of the DLL that is being loaded by DVTA, and that is dwrite.dll. So let me go ahead and do that now. So we're just going to say dwrite, so dwrite.dll, and we're going to just generate that DLL now, and then we obviously need to transfer it onto the target system, or rather download it, and we're going to do that using the student user account or the attacker machine, where we have access to the student user, just to show you that you know, we should be able to make changes or write or download our file into the program's installation directory or its working directory. So we've generated that now. What we can do is set up a web server. So we'll just use Python and the module simple HTTP server, and we'll set up a web server on the Kali Linux system on port 80. And now we also need to set up our handler. So I will just copy my IP, my Kali Linux IP just one more time, and I'll say MSF console, and we'll set up our handler to receive the interpreter session when the DLL is indeed executed. So we'll say use exploit multi-handler, set the payload to the one we used when generating the payload to the MSF Venom. So set payload Windows interpreter reverse, let's do that here, interpreter reverse TCP, set L host to our Kali Linux IP, and I think the L port should already be set to the default, which is 4444. And now we can pretty much just we can just run this here, and we have the handler running, and we also have the web server that's hosting dwrite.dll. And now we can move into the attacker machine where we have access to the target system as the non-privileged student user. And now from this point on, you know, we can pretty much utilize, again, we can just download it in here, or we can go directly into that directory, but I think we can just do it on the desktop of the student user. So I'll just say desktop like so, and we can then say IWR, use basic parsing. Let me make sure I type that in correctly. Use basic parsing, and then the URI of the web server that's running on the Kali Linux system. And I'll just paste in the Kali Linux IP there. The name is dwrite.dll, and the out file is just going to be, we'll just call it dwrite.dll. So dwrite.dll, and we'll hit enter. And in this case, it's telling us that that's not found. And I think I know why, because I did not spell dwrite correctly here. There we go. And we should have it now on the desktop, and we can now copy it from the student's desktop. So if we say desktop, there we are. And we can now go in here, local disk, users, administrator, hold on, actually no, that will probably not work. Yeah, so we'll need admin privileges. So that's the consent form there. So we can actually just do it from the target machine tab as the administrator user. So I'll just go into this PC, users, and student desktop, and I'm just going to copy this here, and the path where it's being called is dvta bin release dwrite.dll. So we'll go into our desktop here in the administrator user account, dvta bin release, and we can see that it didn't exist previously, so we can just hit paste. And now we'll close dvta, and we can actually close procmon. We don't really need it at the moment, but now hopefully when we click on dvta, that DLL will be called, and we should get a interpreter session. There we are, indeed we do. And because we executed the program as the administrator user, we now get an elevated session. There we are, and have successfully elevated our privileges through DLL hijacking. And again, in this case, we have simulated what would need to happen. Pretty much, you know, the program will execute with the privileges of the user that's executing it. So if I executed dvta as the student user, then we would get an interpreter session as the student user, or with the privileges of the student user account. So that pretty much brings us to the end of the practical demonstration section of this video.